Welcome to the Explainer. Today we're tackling a modern Java feature that is an absolute boilerplate killer. I'm talking, of course, about Java records.
All right, so here's how we're going to break this down. First, we got to understand the problem. All that endless boilerplate code. Then we'll introduce the solution, the record. We'll see what you get for free, what rules you have to play by, and, believe it or not, how you can still add your own special logic.
Okay, so to really get why records are such a big deal, we kind of need to take a step back. Let's look at the old way of doing things, the way we all used to write data classes before this came along.
I know it sounds nuts, but it happens all the time. Think about it. A super common task, right? You just need a class to hold an employee's name and their ID number. That's it. These things are everywhere in Java, these little data carriers.
And just for those two simple things, you're suddenly responsible for all of this. You've got your private final fields, you have to write a constructor, you need getters for everything, and then, oh boy, the fun part. Correctly implementing equals, hashCode, and toString. It's so much ceremony for something so simple, and it's how you end up with a 50-line class for a two-field object. So that's the pain. That's the problem we're trying to solve. Now let's see how records come in and offer this beautifully simple modern solution. And this is the magic right here. Just look at that. The whole 50-line monster on the left, it's the exact same thing as that one single line on the right. One line. That's it. It's a massive simplification. It's a game changer.
So what is a record, really? Well, it's a special kind of class. A good way to think about it is, how an enum is also a special kind of class? It's like that. Records are designed for one specific job, to be a totally transparent, unchangeable container for your data. Nothing more, nothing less.
So you're probably asking, okay, but where did all that code go? Well, the Java compiler just does it for you. It's amazing. When you write that one line, you get all this crucial stuff generated behind the scenes, totally for free.
Yeah, that one little line tells Java, hey, go ahead and generate all this for me. You get private final fields so the data is locked down, it can't be changed. You get public methods to access the data, you get a proper constructor, and, maybe the best part, you get correct implementations of toString, equals, and hashCode. And we all know how easy it is to mess those up when you write them yourself.
Now, here's a neat little detail. There's one small difference in the methods that get generated. You'll notice the accessor methods don't have that classic get prefix. Instead of getName, it's just name. It's a small thing, but it just makes the code feel that much cleaner.
The compiler also gives you something called the canonical constructor. Now, canonical is just a fancy word for the main official constructor. It's the one that perfectly matches what you declared in the record's header. It forces you to provide a value for every single field right when you create the object. There's no way to create a half-baked record, which is a really good thing.
Okay, so with all this power comes a few rules. You can think of them as guardrails. They're there to keep records simple and focused on their main job, which is just carrying data. These aren't random limitations. They're what make records so reliable.
The number one rule, the core idea, is immutability. Once you create a record, you can't change it. Its state is final. That's why all the fields are final under the hood and why there are no setter methods. And honestly, this is a massive win. It makes your code way safer, especially with multiple threads running, and just easier to understand what's going on.
All right, let's break down the do's and don'ts. Inheritance is a no-go. A record can't extend another class, and you can't extend a record. It's a closed box. But you can implement interfaces, which is super useful. And you can add your own methods, both instance and static. The main restriction is about the data itself. You can't sneak in extra instance fields. Everything a record holds has to be declared right there in the header.
Now you might be thinking, okay, they're simple, but are they too simple? Are they inflexible? And the answer is no. You can definitely add your own logic. A really common place to do this is right inside the constructor.
For example, what if you need to validate some of the data? Let's go back to our employee. What if you want to guarantee that the employee number is never negative? You need to put a check in there somewhere, right? You need to catch that before the object gets created. And records have this really elegant solution for exactly this problem. It's called a compact constructor. It's a special syntax. You just write a constructor, but with no parentheses, no parameter list. Inside that block, you can put all your validation logic. The compiler is smart enough to take your code and stick it inside the real constructor for you.
It saves you from having to write out all the parameters and assignments again. It's a brilliant little shortcut. So after all that, after looking at all the rules and features, we come right back to this one beautiful line of code. It gives you a complete, unchangeable, safe data class. I mean, when you put it side by side with the old 50-line version, there's just no contest. The clarity is on another level.
So, what's the key takeaway here? It's simple, really. The next time you find yourself needing a class that just holds data, make a record your first choice. Seriously, you're going to write less code, your code will be safer because it's immutable, and anyone else who looks at it will know exactly what's going on instantly. It's pretty amazing when you think about it. A single feature that just wipes out mountains of boiler code, it really makes you wonder, right? What's the next big simplification that's waiting for us just around the corner in programming? Something to think about. Thanks for joining me on this explainer, and I'll catch you on the next one.